Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, once again bringing you what to look for in the night sky, this time for the week of November 29th. So actually, mostly the first week of December 2021, but starts on the 29th on Monday there, the way we start these videos on a Monday. And I thought that this week we would turn our attention to Orion, which we probably ought to do once a year or more. It's a rich region, lots of things to talk about, and it really dominates the winter sky in a big way. And so I think it's great for us to look at this. This is a good time to look at it. For me, it's climbing above the horizon right now at about 8 o'clock. So about 8 o'clock, it's climbing into the evening sky where I can see it, and it'll be well placed the rest of the night. You know, I get up and go outside at 4 o'clock in the morning. And 5 o'clock in the morning still. Orion's beautiful right there, and it's just going to get earlier as the month progresses. So by the time we get to mid-month in December, Orion will be rising by, well placed in the sky by 8 o'clock and rising into the sky where we can observe it by 7 o'clock in the evening. So this is, this is an all-winter kind of. It's not just this week. Sometimes we talk about things that are moving, like the planets and so on, and even those don't move that much, and so it's often we've been tracking. You've been watching these things. We've been tracking Jupiter for the entire month of November, and continue to do so into December. That's not the case here. This is something that could apply anytime from October through April, really, for what we're going to talk about here. To get out and observe Rigel, get out and observe Orion. It's a great constellation. This is a good time. December and January, good months to do that, since it's up in the evening sky. So let's talk about, first of all, the Arabic name for this constellation, Al-Jawza, translates, according to places that I've read, but Alan's star names that we refer to all the time in these videos, the central one. And so this is, I've read other writers ask, well, we don't know why the central one in Arabic culture, but we would say that, it's a big, prominent constellation, dominates the sky here for many of us, depending on where you are. But, the celestial equator, that's the thing. One of the things that makes this constellation great is the celestial equator runs right by the belt of Orion right here. And so if you're in the southern hemisphere, you see Orion pretty well. And if you're in the northern hemisphere, you see Orion pretty well. You have to get way out toward the poles before you don't see much of Orion. And even at the poles, you're going to see some of Orion. So really, really fabulous constellation to pay attention to. So we'll try to give you a little bit something different each time we look at Orion over the years, but we'll keep looking at Orion. And I recommend that you get out and observe it with the binoculars, with a small telescope, and just observe the stars a little bit. I've marked, again, a busy board. This is a few weeks in a row we've started with a busy board. I've tried to outline the pattern of Orion. Orion's familiar to many people. There's the three stars of the belt, the shoulder stars, Betelgeuse and Bellatrix, and Cepheid and Rigel as the leg stars. Rigel and Betelgeuse are the bright ones. I've marked the names on here and the magnitudes like we did last week. And you should go back and look at last week's video and look at those magnitudes where we looked at Capricornus, where we looked at Pisces, where we looked at Andromeda, and see just how bright these stars are. Remember, the magnitude system counts backward, so a lower number is brighter, and it's a logarithmic system, so every step in magnitude is a multiplicative factor of 2.5 in brightness. We had nothing in the three cornucopias that we looked at last week. We had nothing that rivaled Rigel or Betelgeuse in brightness, 0.4, 0.2, roughly speaking, the magnitudes of these two stars. And we've probably talked about this before. Rigel's very red, Rigel's very blue, Betelgeuse is very red. And so if you have a couple of paper towel tubes and you can point your right eye at Rigel and your left eye at Betelgeuse, that color difference is just amazing, just really fun to do. And so worth going out and giving it a try to see that color difference. Betelgeuse is a post-main sequence star. Main sequence stars are fusing hydrogen into helium into their cores, and after they run out of hydrogen to fuse into helium in their cores, they go through several different stages of nuclear burning. But most of the time, they spend fusing hydrogen into helium in a shell around that central core, or helium into carbon in a shell around that central core, oscillating between those two different fusion shells They're on the asymptotic giant branch, and then the big heavy stars can be fusing other things in layers as well too. Although most of their luminosity, most of their energy is coming from hydrogen fusion in a shell or helium fusion, and it moves outward through the star. So what really happens? Well, the point here is red means very cool star, very hot star, very big difference in temperature. But the reason Betelgeuse is cool, and one of the things that we've emphasized in the astronomy class that I've been teaching all fall, we emphasize always in the astronomy class, is that when things fall inward under the influence of gravity, they heat up. When things get pushed outward, in gravitational field and gravitational attraction, they cool down. So as things expand, they cool. As things contract, they heat. And this idea, thinking about hydrostatic equilibrium, the balance of those things and where the balance occurs and doesn't occur, and that really drives a lot of our thinking about how the universe works and how the universe has evolved. So it's an important idea for us, and we keep circling back to it. And what happens in Betelgeuse is the core is actually very hot. So the core of Betelgeuse is a very hot core, and that high temperature causes a higher pressure that pushes the outer layer out. And when the outer layer of the star expands outward in the giant phase, then it cools down. And that's why red giants are red, is because they have this cool outer layer that's cooled down from being pushed out by the hot core. A lot of fusion going on there. Very luminous star, but cool. And we usually think of luminous associated with high temperature. Rigel is luminous because it's hot. Luminosity is proportional to the temperature to the fourth power. And so the surface temperature to the fourth power and the radius squared, it tells you that the Betelgeuse must be a very big star to be as luminous as it is and as cool as it is. Anyway, those are great stars to look at. We don't have time. We're running out of time. We don't want to talk forever to go through the names of all of these stars, but you can see I've written the names up here. You look at the belt stars. So anyway, let's go back to the magnitudes. 0 magnitude stars here. If you look at the belt stars, Alnilam, Alnitak, and Mintaka are 1.7, 1.7, 2.2. Bellatrix, the shoulder star, 1.6. Safe, the other leg star, is 2.1. So everything between 2.1 2.2 and 1.6. Those are among the brightest stars we looked at last week. So the stars that are significantly fainter than Rigel and Betelgeuse are as brighter than all of the stars that we looked at last week. And so this is a bright constellation. That's why it's so well known. Big and it's bright. And these stars are easy to see. They sparkle against the dark winter sky where the cold weather, if you live in the northern hemisphere, the cold weather has frozen all the moisture out of the air, and these glitter against the dark background. They're just beautiful. So look at those across here. These have names, Arabic names that are associated with the belt here. Al-Natak, the girdle, Al-Nalam, string of pearls, Mintaka from Al-Mintaka, the belt. And so these we associate with the belt. We see some of the other names associated around here. We'll save those for another time, so we won't go through all of those. I want to give you a couple other things to look at while you're here. So the Orion Nebula, the Sword of Orion, Saif is translated as sword, Saif al-Jabbar, sword of the giant. And so this is sometimes called Sword of the Giant, but we usually associate the sword here with the Orion Nebula, the Great Orion Nebula, Starbirth Nebula. Nebula can be different things, have different causes, but this is a starbirth region. And it's visible to the naked eye. You can see it there. It's great in a pair of binoculars. It's really great in a small telescope. You get a chance, get out, point binoculars, point a small telescope at the Orion Nebula, spend all winter doing it. It's really something to watch here. So that's something good. This whole region is sort of embedded in nebulosity. So there's gas and dust and material around this region. And so you can sort of get a sense of the bubble of nebulosity that encompasses the Orion region. But another bright patch of it is above Al-Natak, just a couple of degrees. So you go a couple of degrees above Al-Natak, pointed up towards Betelgeuse, and you run into M78. M78 is a bright patch of that nebulosity. So that's worth checking out too, in binoculars and in a small telescope. So those are great targets for you. This region also has a number of open star clusters. None of them are what I would call spectacular. I've labeled one of the ones I like up here, NGC 2194. So if you start at Betelgeuse and you go about 3 degrees up to Mu Orionis. And then you go about that same 3 degrees, maybe a skosh more, further on up. Just follow that line up from Betelgeuse to Mu. Now, Mu is a 4th magnitude star. I guess I forgot to write that down. It's about 4.1 or 4.2 magnitude star. So it's a fairly visible star, but it's really faint compared to all of these other stars of Orion that we've been looking at. So you find Mu up there, go about the same distance, a little bit more, and then just off to the left, just off to the east of that line that we draw from Betelgeuse to Mu is NGC 2194. And you might be able to see that as a richness. There's a lot of stars in this region, and so it's just a richness and enhancement of the stellar density in this part of the sky. And a pair of binoculars or a small telescope. There are others around here, or quite a few others around here, but they are hard to pick out sometimes, and they're just again, just slight enhancements in the stellar density on the sky that we see. NGC 2194, I think, is one of the better ones for you to try to find up there. So give that a shot. In terms of double stars, we've been looking at double stars somewhat. Probably one of the best ones, about a degree below, about a degree to the south and west of Alnitak, the lower belt star that we have right here, is Sigma Orionis. It's about a 3.7 magnitude star. So 3.7, it's again bright enough to see, but looks pretty faint compared to all of these other stars. But that's a system. That's a multiple star system. So there's groupings of stars, and there's some very hard to separate and some relatively easy to separate. And you see that pops apart as a nice cluster of multiple stars in there, and is a great target for a small telescope. So I recommend that highly. Rigel is itself a double star, and you need a pretty decent telescope. Maybe it's 10 arc seconds, maybe it's a little bit less than that, the separation between Rigel and its companion right here. But Rigel's so bright, it makes it hard to see fainter stars near it. And so you need to do a little bit of work to pull that apart. But that's a pretty good double star to try. So get out, take a look at all of these things, and see what you can see. Of Orion, get to know Orion, get to recognize Orion, get to appreciate Orion every time it appears, and check out some of these objects that we've talked about here. And good observing, everybody. We hope you have a good week, and we'll have something new for you next week.